number 13, this could be a long one because I see that we have two x's here, and those usually take a little bit longer. So my first step is going to be to take it out of functional notation. My next step is going to be to switch or to swap the x and the y's. So I have x is equal to 2y minus 3 and y plus 4. So I'm trying to get y by itself, and I don't want there to be really the y's in the denominator here. So I do want to multiply by y plus 4 on both sides. So what that's going to leave me with is x times y plus 4 is equal to 2y minus 3. So now I can distribute the x, and I have xy plus 4x is equal to 2y minus 3. And kind of like in number 11, because I'm solving for y, I want all of my y terms on one side and all of my terms that don't have a y on the other side. So I want my y terms on one side. So I want to move this guy over there, and I'm going to move this guy over there. So xy minus 2y is equal to negative 4x minus 3. My x doesn't look too good. X minus 3. And again, why we do that, because we're trying to solve for y, is because if you have all of your y's on one side, then you can factor this. So you can actually factor out a y. And when you do that as a GCF, you only have to write it once off to the side. So that's kind of nice. And then our last step is going to be to divide both sides by x minus 2. So y is equal to negative 4x minus 3 over x minus 2. So f inverse of x is equal to negative 4x minus 3 and x minus 2. And if you had, so just like in the other inverse problems, there's multiple correct answers. Let's say you moved all the y's to the right hand side and all your x's to the left hand side. Then you could get the answer negative, not negative 2, 3 plus 4x and 2 minus x. So again, notice how all of our signs are opposite here. So either one of these is okay for your answer.